The approximate composition of the air today is 78.08% nitrogen, 20.95% oxygen, 0.93% argon, 0.04% carbon dioxide, and between 0 and 4% water vapour. Nitrogen, argon and oxygen can be separated from the air by liquefaction followed by fractional distillation. Firstly, the air is filtered to remove dust. It is then cooled in stages to minus 200 degrees Celsius, at which temperature air is a liquid. As it is cooled, water vapour condenses and is removed by absorbent filters. Carbon dioxide is then removed at minus 79 degrees Celsius when it freezes. The oxygen liquefies at minus 183 degrees Celsius, argon at minus 186 degrees Celsius, and nitrogen liquefies at minus 196 degrees Celsius. The liquid nitrogen, argon and oxygen are then separated by fractional distillation. Let's have a look at this process in detail. First, as we said before, the air is cooled to minus 200 degrees Celsius and passed into the fractionating column. It is then gently warmed. The temperature rises from minus 200 degrees C, and when it gets to minus 196 degrees Celsius, the nitrogen boils off and is collected. When it reaches minus 186 degrees Celsius, the argon boils off, and when it reaches minus 183 degrees Celsius, the oxygen boils off. Now, the important uses for nitrogen are creating an inert atmosphere for chemical processes, the Haber process for the manufacture of ammonia, gas chromatography, packing oxidizable foods such as ground coffee, and also liquefied nitrogen can be used for the freeze-drying of food and preservation of tissue samples. Now let's have a look at argon. Argon helps us create an inert atmosphere around filaments in light bulbs. Much more spectacularly, blue argon lasers are used in surgery to weld arteries and correct eye problems, and scuba divers use argon to inflate dry suits. Finally, oxygen is essential for our breathing and survival, and therefore it's used in medicine for breathing equipment. But that's not its only use. Oxygen is also used for steel making. The oxygen is passed through impure molten iron in the blast furnace to oxidize and remove the impurities such as carbon, sulfur, phosphorus and silicon. Oxygen is also an essential part of rocket fuel, and it's used to fuel oxyacetylene flames for cutting and welding.